All right, thanks everybody. Together with me, I got Desmond here and also Chirag. So we are basically, very passionate about the Kubernetes technologies. So we realize that there is a lot of stuff we need to learn. And for any single person, you can't be, very good on every area. That's why I set up the Kubernetes Singapore Meetup. I set up the account back in August, actually last month. So previously, I joined a couple of AWS, Meetup user group, and back to July, and then after the July session, I realized that there are a lot of people very interested in Kubernetes, and even from an AWS user group, every time I can see the topics about Kubernetes. That's why I set up this group, to just focus on Kubernetes. It could be any different Kubernetes distribution, could be, OpenShift, etc. So my name is Yongkang. I'm super excited here to share, to learn from each other as well. So I'm a principal container specialist. So I do support the whole, APAC region. So by now, I'm actually 49 times multi-cloud certified. It doesn't take me a few years. I did it in 2 years. Okay, and I also, managed to get certified on Kubernetes 3 times. I did not do the basic one, but I did the hard one, CKA, CKAD, and the CKS. I'm also AWS community builders, specialized on containers. So super excited to be here. And also proud of being part of the Calico Big Cats program. So container networking, Calico is one of the, popular one. So Chirag, do you want to introduce yourself as well?
Sure. Yeah. Welcome everyone to our first meetup, the brand new group which we started as Yong.
Just call me Yong, makes it easier.
Yong mentioned. Okay. So the whole vision of this group is to share more Kubernetes no longer just a one platform, but it's under Cncf, Cloud Native Computing Foundation, and the ecosystem is growing. Lot of projects which is helping, supporting to build this ecosystem. And yeah, the sources are less as well as the use cases are out there. So we would like to request you also to share that your learning. Again, this meetup is going to be there only few people are but it's focused. Okay. So whatever
we can't really hear.
Sorry guys, actually they can't hear.
Sorry. Okay, so again, this group is open, so feel free to share your feedback, share your ideas that how we can grow, as well as we are open for the speakers. It's not just only about a Kubernetes, but their entire ecosystem, all the CNCF projects, and we want to do it regularly. And about me, like I'm always a community contributor. I was part of multiple communities since the start of my career, being a co-organizer of AWS community group or user group back in India and active contributor here also, as well as I was organizer of CNCF Kubernetes Kolkata, which is a one city in eastern part of India. And that is where I would like to share my learning also being as a community contributor. And professionally, I'm working in a company named Orange Business Services. It's again a role around customer success manager. So understanding about the customer journey. So my entire career is around cloud, and AWS is something from day one of my career I'm doing. So Kubernetes is again playing a major role. So everyone need to learn that, or at least to know, be it a sales, pre-sales, a delivery guy, or a different role. Thank you. Desmond.
So, hi everyone, Desmond here. I really appreciate you guys coming. But just want to echo what from what I've seen, there's change from what was
So with me today, I have Keshav. He's also from the AWS as a faculty Yongkang for on the Meetup for very kind of related to this student. Right? There are a lot of things to explore. So I'll pass it on to Keshav after this, right? We'll be our first speaker. Keshav is from our communities, correct? I'll let him do the introductions, but one of the very members in everything. Right? Thanks, Desmond. Yeah, before we get into the session, I'd like to, thanks our sponsors. So first of all, AWS to sponsor us the place for us to meet up in person together. And also thanks Veeam actually to provide the food, the pizza, the drinks for us to enjoy. And also I'd like to thank my daughter actually, Louisa. She's actually organizing the Zoom meeting for people to join remotely. So first of all, I want to talk about our mission. That's something I put together with my friends Chirag and Desmond. So basically, we are very passionate about the Kubernetes. So our mission is to accept the Kubernetes adoption. So we are learning from the community, and we are sharing the best practices. That's our mission. We're trying to run this event monthly. And I also looking for volunteers to help us. So the reason is Kubernetes is so hard. You guys see this eye chart. There are so many different ecosystem. It's just you can't be expert in every area. I did the 3 times Kubernetes certification, but I still feel like the more I learn, I feel like the more I don't know. So that's why I also need to learn more. Right, this slide probably makes a little bit easy to say. So things like all different area you talk about the CI/CD pipeline, could be security, could be container networking, could be container runtime. Definitely, that's a lot. So that's why I was thinking we can use this platform to help each other to learn quicker, learn faster. So today's topic, Desmond mentioned earlier a little bit. So we will first of all talk about the Kubernetes trends. That's Keshav from AWS. We will talk about the general Kubernetes trends. And then I love hands-on. So I was talking to Desmond from AWS. We are going to give everybody the lab access. AWS provided the lab access for us to create an EKS cluster. So that's one of the popular Kubernetes distribution. And once you have the EKS cluster ready, we need to think about it from day 1, day 0. The backup also very important. So part of my automation, I created the automation about 1 year ago. So basically how to spin up a EKS cluster in 15 minutes, how to enable container backups in about 3 minutes. So we will give everybody the access, give everybody the lab guide to try all different recovery options. But first of all, you need to have an EKS cluster ready. So that's the topic we're going to cover. So after the session, feel free, to have a little bit more social networking, could be any Q&As. Okay, future topics, we are planning to do monthly. Could be, we talk about container networking security, Kubernetes security networking. And it could be we're talking about, monitoring, logging, troubleshooting, all different areas we're going to plan to cover. And Kubernetes storage. So there are a lot of storage options up there. What about container migration? So customer might want to move the application from on-premises to Amazon cloud, or could be other cloud. Could be they move to cloud, they don't realize, could be considering, I do realize that there are some customers, they initially move to the cloud, then they planning to move back to on-premise. One of the big reasons is the cost. So I know one of the customer from a Philippines. It's a fintech company. They move everything into one of the largest public cloud. Then they realize that the cost is a problem. They're running Kubernetes like 1,000 nodes in production, and additional 3,000 nodes in test dev environment. That's a huge environment. Think about that scale. It does cost a lot. So we talk about the container migration. When customer want to move to the cloud, how we can help them to easily to move to the cloud. When they realize that there are some cost issue, or could be moved to a different cloud, how to make that happen easily. That's a container migration piece. What about serverless? What about service mesh and the streaming or messaging system? Definitely, that's a lot of areas. Container registry. There are a lot of options. Amazon also have their own, Amazon ECR. In a container runtime, initially, Docker pretty popular, but later in the latest version, container D will be, the default for the Kubernetes and the CI/CD pipeline, etc. That's a lot, right? It's hard for us to learn. That's why, we have this platform for everybody to learn to share. So we are also looking for helpers. So like, everyone's social is very important. Yeah, feel free to take a photo to post it from LinkedIn, Twitter, or any social platform. And we're also looking for volunteers. Maybe you have an idea. Maybe you are running some project. It's, it's good for you to showcase. You can practice here, right? And helpers, any helpers. I only registered the domain, KASUG.com. That is pretty easy to remember, right? But right now, I just redirected to the Meetup link. Yeah, I'm not, pretty good on how to, set up the website. If anyone interested to volunteer to help me create the website, that's very much, appreciated. I also looking for sponsors. So right now, I don't really have anyone sponsor us the swags. It could be in the future. We're inviting some of the other vendors to join us and talk about it, share the product solutions. Not only for us to learn, and for the vendor, they are willing to sponsor you some swags as well. Oh, we already have AWS already provided. Okay, that's good. That's good. Yeah, I don't know where it is, but anyway, not for, yeah. Yeah, too bad. It's not for people on online only. Oh, okay. Yeah, we do have some notebooks. Looks like a pretty nice from AWS. Thanks to the AWS sponsor these. But yeah, let's see how we are going to give out. We only have like a 5 or 6 here, and we are also looking for feedbacks. Yeah, give us feedbacks how we can improve, how we can make the better. Any comments, feel free to let us know. Yeah, that's pretty much all I want to cover for now. Feel free to follow me, to send me email, connect me via LinkedIn, or I also have my YouTube channel, also pretty popular, just to focus on the Kubernetes. So Amazon is one of my popular ones. Yeah, that's all I want to cover for now. I'm gonna hand it over to Keshav to talk about the Kubernetes chains.
Okay, I think we are all set. People on the online channel should be able to hear me now. Just to introduce myself, my name is Keshav. I'm a solutions architect at Amazon Web Services. I have been working in Singapore for a few years now, primarily in banking technology sector. Started at AWS about an year ago. Always wanted to come into the cloud side of things and help customers build out their cloud-based solutions. So right now, I work with a number of enterprise customers in Singapore, helping them on their cloud adoption and cloud migration journey. I'm also part of what is known as Containers Technical Field Community in AWS. So all of the solution architects are part of one TFC or the other. Over the last 3, 4, or 5 years, I've been building applications on Kubernetes, deploying them in production, and something that really excited me. I mean, someone remembers the days when you had to go and raise a ticket or request your friend in infrastructure team to deploy a new version of JDK. All those days are gone because now you can containerize everything, package everything. So with containers, the power comes back in developers' hands, right? So you're no longer at the mercy of the infrastructure team just to get your environment. So I think personally for me and my application development team, it really eased our way into production with containerizing a number of our applications. Today, Desmond and the rest of the group requested me to talk about some of the Kubernetes trends that we are seeing in the region. So I'm going to talk about a couple of things, or maybe 3. The idea is to give you an overview of some of these aspects, and if interested, we can go into deep dive in one of the coming sessions. Okay. Can you mute this, Shane? Okay, and also, I'm going to be nice. I'm not going to put any scary pictures like Yongkang just put us. So, I do believe that this picture was really to scare you into submission. So don't fall for that. Kubernetes is not that difficult, right? So if you actually go for understanding the concepts, it actually makes your life much easier, right? So okay, so what are some of the trends that we are seeing in numbers? Okay, before we do that, I just took a look at the Cncf survey for 2021, right? And I saw some interesting numbers in there. The survey was conducted across the globe. There were 2,302 respondents to the survey. And one question that was asked to them was, are you using Kubernetes today? Overwhelming 96% people said they're using Kubernetes today. 10% of those 96 are actually not in dev or test or production. They are just evaluating. But 86% are running Kubernetes cluster, right? So that's an overwhelming majority of respondents that are using Kubernetes day in and day out, right? So Kubernetes is mainstream, right? It is not something that is new or fancy. It is the mainstream way of developing and deploying applications. Another question that was asked on the survey was, what are some of the challenges that you see in deploying containers, right? And not surprisingly, a large number of people, 21% of them, said networking is a complex area while deploying containerized applications. And I thought that will come up. Networking does become complex where you start thinking about a day in life of a packet from one pod to another pod across the various boundaries, right? So it is going from container to pod to host across the network to another pod. But what was surprising for me was that an even larger number of respondents said logging is difficult, right? 23% said logging is difficult. They find logging across the number of ephemeral pods that are running on your cluster. How do you actually aggregate that in a way that is not intrusive to the applications, in a way that does not take up a lot of effort from your infrastructure teams, right? And the third one, monitoring. Monitoring is high on the list of the people trying to resolve this mystery on how to get monitoring right on Kubernetes cluster, right? So yeah, I mean, those were surprising numbers for me, but looks like out in the field, people are still trying to identify the best way to capture logs and monitor their applications running on container platforms. So the first topic that we're going to talk about is observability, given that logging and monitoring are some of the items that are high on the agenda, right? What is observability? Observability is the ability for you to infer what's happening inside the system based on the external outputs that you can see from a particular system, right? So a cruise control system for a car, right? It is a control system, and it is able to maintain constant engine power output to maintain constant speed, right? So it's a perfectly valid example of a control system based on observability. In software systems, obviously the term means that you are able to infer how well your application is performing based on the telemetry data that you receive out from the application, right? So I just said that observability is measure of how well you can understand your software system based on what you observe for the system, right? And this could be simple things like, what is the CPU utilization for the service, right? How many requests are being completed under, say, 70 milliseconds, right? The API is handling X number of HTTP requests per second, right? So if that number goes very low, you know that something is going wrong. You need to have a baseline to say, okay, my service actually operates on a daily basis at around 12,000 requests per second. For somehow at 2 p.m. in the day, it's gone down to 500. So there must be something wrong, and I need to investigate, right? So this needs to be obviously automated, integrated into your monitoring and analytic solution. But before that can happen, your system should be able to emit this sort of telemetry data, right? And the three pillars of observability, the observability signals, metrics, quantitative information about your processes aggregated over a period of time, right? So the number of API requests processed within 70 milliseconds over the last 5 minutes period, right? So that is a metric that is coming out. The CPU utilization of your service. Logs, I mean, logs are everywhere. Everybody understands log, whether it is developers or operators. Logs are timestamped messages emitted by your service. However, one thing to note is that logs on their own might not be very useful unless they are correlated back with metrics and traces, right? So if you see a metric going up or down, how do you actually go back and understand what is causing it? You want to go and look in the logs, but where is the correlation? That is the piece that is currently missing in some of the solutions that are out there. Traces or distributed traces track the path of a request through a distributed system, right? So these days, you have most of the systems built as microservices architectures, number of services built on various different platforms running across the network. And you need a way to be able to correlate a request going from service 1 to service N. Without that, you have no chance of actually debugging a distributed system, right? This is not something that you can reproduce locally. This is not something that you can identify or recreate on your local machine, right? So for you to effectively monitor and observe a distributed system, traces are very important, right? And what are the challenges that developers and operators face today? There is lack of standardization. There are multiple frameworks, libraries, agents for ingesting, storing, and visualizing this telemetry data, right? So if you come from Java world, there were like 50 odd library logging frameworks, right? And you had to spend a lot of time just figuring out what is the logging framework that you're going to use for your application, right? So with this, obviously, there is proprietary protocols, proprietary data models. There is no data portability across the various observability backends, resulting in obviously in increased stress on the developers, maintaining and managing and making your applications work with all of these different libraries and frameworks. So then, what's the solution? And we believe OpenTelemetry is one, right? So OpenTelemetry is an open source project. It is a CNCF incubating project. And what it strives to achieve is a standardized vendor neutral protocol for telemetry data. Okay, it not only specifies the protocol, it has actually implementations in various languages. I think on the last count, all the popular 6 or 8 programming languages have got libraries that allow you to instrument your applications in an automated manner, right? So, and they also offer SDKs. So you can actually leverage the SDK APIs in your applications as well. as a quick way to get your application started, you would actually use the automated instrumentation mechanism, right? So with Java, for example, it just means that you need to include an additional jar specified at runtime, which attaches to your code and starts instrumenting your application. What is instrumented? The HTTP calls coming in, HTTP calls going out, JDBC calls, all of that is already automatically instrumented without developers actually having to write anything for that. The project also looks to deliver one collector binary across with support for multiple backends. So with just one binary, you should be able to ingest data from multiple sources and be able to publish it out to multiple destinations. The collector binary can be deployed both as an agent and as a daemon. It has, and obviously in Kubernetes world, it has a Kubernetes operator, right? Okay, so I put up this slide just to talk about open telemetry vision, right? So on the left, this is what you have: separate collections across logging, tracing, and metrics, right? So there are different agents doing these different tasks of ingesting logs, traces, and metrics, and actually pushing them into separate backends. And because these are all separate backends, separate protocols, different data models, you can't really integrate these three pillars of observability. Right. And the vision of OpenTelemetry is, as I said, to have a single collector binary that can instrument your application and can work across logs, metrics, and traces and publish them into one backend. I mean, just looking at this picture, you can realize the power that comes with this integrated backend with correlated logs, metrics, and traces. Right. Today, the project actually does have APIs and collector agents for traces and metrics. Logs is something that is not currently available from the project, right? So the project does acknowledge the fact that logging is very deeply embedded with various different libraries and frameworks. And they do have a vision of getting the logs to work with OpenTelemetry ecosystem by defining a common log data model, right? The vision is to have all of these existing libraries be able to produce log statements in this common log data model, which can then be ingested into a common backend. So logging implementation is not available yet. Metrics and traces are ready to go, available for use in production. So what does an OpenTelemetry collector pipeline look like? So on the left, you have an application, and you instrument that application by integrating a collector binary with the application, right? And what is this collector pipeline? So this collector pipeline has got three distinct steps. It has got a set of receivers which can collect data from multiple sources. These receivers can be push-based or pull-based. So for example, this receiver could be a drop-in replacement for a Prometheus receiver, right? So Prometheus is a pull-based mechanism where an application exposes an endpoint and it's publishing or is exposing matrices at that endpoint. Prometheus goes and pulls those metrics. So there is a drop-in replacement for a Prometheus receiver. So in your collector pipeline, you can say the receiver is Prometheus receiver, right? You then process the data. If you need to filter, transform, or enrich the data, the telemetry data, and then you have exporters, right? So once the data comes in, you actually might, a possible pipeline could be you take in the metrics from Prometheus in Prometheus format, you transform it into AWS embedded metrics format, and publish it into an AWS solution like CloudWatch. So that is possible if you want to. The other thing that is possible, obviously, is you don't transform, you just have the Prometheus metrics, you can publish them into a Prometheus installation or Amazon managed Prometheus for that matter. Yeah. Okay, so I was just briefly talking about this. So how does it look like in a Kubernetes application, right? So you have a pod which has got the application container, and we have an AWS OTel collector. So AWS OpenTelemetry collector running as a sidecar in the pod. So AWS offers its own distribution based on totally fully compatible with the upstream specifications by the OpenTelemetry project. And what it does is it is able to ingest the traces and metrics from the application container. And as I said, for logs, today, FluentBit is the preferred solution, right? So the logs that are generated by the container via std out or std error are ingested by FluentBit. And then the OTel collector through its pipeline is actually able to push the metrics into Prometheus. The metrics can actually be, so you can fan them out into multiple systems as well. So metrics can go to Prometheus. You could have a pipeline that actually does the transformation and publishes them into CloudWatch as well. The logs from FluentBit go into CloudWatch, and the traces today go into X-Ray. Yeah. So yeah, before we jump on to the next topic that I just wanted to talk about, Git Ops. Yeah, as I said, observability is one area where we see a lot of interest from our customers understanding this open telemetry project and trying to implement a tool that is consistent across the three pillars of observability. And that is where, as I said, we see a lot of traction among the customers. The next thing that I wanted to talk about is Git Ops, right? So yeah, I mean, I'm not going to dive deep into the open telemetry or observability. That's perhaps for another session. Today, I'm just talking about some of the trends that we are seeing in the market. Git Ops. So Git Ops has been quite popular over the last few years. And essentially, the basis for Git Ops is for you to define the state of your system as a configuration in a system that is version controlled and immutable. And that system, more often than not, is Git, right? What you are looking to define is not just your cluster configuration, but also your applications. Once that configuration is specified and is available in a version controlled Git repository, you then have automated agents that can read the repository and then sync it with the cluster state. So there are agents that are continuously syncing the desired state that you have specified in Git and syncing it with the cluster. And then if there are any drifts, so you create a deployment in Kubernetes, you specify 3 replica pods to be created, and an automated agent comes in, it looks at that specification and creates the application in Kubernetes cluster. But then an operator goes in and changes the replica count from 3 to 4. So the cluster now has 4 pods. Git says there should be 3 pods. So the automated agent actually syncs the application back and it brings the number of pods down to 3. So Git is your source of truth in the terms of cluster operation. Yeah. And one project that we see, okay, before we talk about the project, so this is the continuous operating model for Git Ops. So on the left, you see the CI pipeline, continuous integration pipeline, and it's more from a perspective of an application. So you have a team of application developers who are building, testing, creating their images, possibly scanning them, and publishing them into a registry, right? That registry could be any Docker registry. Once they do that, and they have got a new version ready to go, the next step is actually to go into Git and update your Kubernetes manifests, the YAML files or the Helm charts, or if you're using Customize, there are tools that support Customize as well. So go in, change the version in Git. Once that happens, the automated agent that we talked about is continuously monitoring Git against your cluster state, and it goes into this loop where it actually picks up the specification and starts the deployment. So, well, all of these tools does offer the capability to observe the deployment. So in case a rollback is required, they are able to do that. And also, as I said, during the continuous operation mode as well, they are continuously observing for any drifts and syncing the state of the cluster back to what is specified in Git. Right? And the one project there which we see a lot of traction on is Argo Cd, right? And I'm just going to talk about the high-level architecture of Argo Cd and how does it work. So Argo Cd comes as a set of Kubernetes controllers, right? So let's talk about the controllers first. So you have an API controller. What is this responsible for? It provides a gRPC and REST-based interface for the UI as well as CLI to actually issue commands against the Argo Cd controller. And then you have the repository service, which is, so just before we go on to repository service, the API actually server is responsible for maintaining the repository credentials, the cluster authentication and authorization, delegating the authentication and authorization to external identity providers as well. And essentially, any commands that you are issuing to Argo, right, which could be sync my application, right, or take this application under your control. So specifying the repository path. So API server is the one that you will issue the commands to. And then once an application has been set up, the repository service is the component that is continuously looking at repository service at the Git repository and gets invoked by any change or event in Git. And the application controller is the actual agent that does sync the Kubernetes cluster as per the specifications provided in the Git repo. So you have got all of these three components working together. You also have a mechanism for hooks, web hooks, which can be triggered pre-sync, post-sync, and actually there is while the sync is going on as well. So there are these various hooks that you can integrate Argo Cd with as well. Okay. Now, Argo Cd gives you what is known as CD, continuous delivery, right? So you have a model with Argo Cd now where the specification of your application is in Git. And as soon as that specification changes, there is an automated loop that goes around and brings the cluster back into what is specified in Git. So that is continuous delivery for you. But then if you take it a step further, we are now talking about progressive delivery in Kubernetes space, right? So how do you actually deploy applications in Kubernetes using blue-green approach or canary releases, right? So how would you go about doing that? So the Kubernetes deployment construct does give you very simple deployment strategy, right? So it offers you a rollout strategy or a recreate strategy, right? But if you want to have a progressive delivery based on canary or blue-green, that's what Argo Rollouts provides to you. So Argo Rollouts is again an open source project under the same umbrella as Argo Cd. And essentially, the way it works is that it extends the deployment controller with what is known as a rollout controller, right? So a rollout controller looks very similar to a deployment controller, but then it has additional configuration for the controller to understand how to go about deploying the application. So you can specify things like the deployment strategy is blue-green or the deployment strategy is canary, and it should do an incremental switch by 10% every 10 minutes. So you can specify things like that. Argo rollouts will obviously only work for those applications which now you are controlling with a rollout controller, right? So rather than using deployment in your Kubernetes manifest, you would use a rollout Kubernetes object, right? So that is what is provided by the project. And the way it works is it actually uses the standard replica sets. So here you see a canary replica set and a stable replica set. So these are standard replica sets, no extensions or no modifications. But then the rollout controller attaches certain labels or metadata to these replica sets. So for every application that it is managing, it has a pair of replica sets rather than a traditional deployment controller which just has one replica set. So our deployment has a replica set which has n number of pods, but with a rollout controller or a rollout, you have two replica sets for you to control the canary or the blue-green between the replica sets. The rollout controller also works with standard service construct with some additional metadata to actually control the traffic flow between the canary replica set and the stable replica set. What you see on the right of the picture are some of the providers, metrics providers, right? So Argo rollouts has a concept of analysis, right? So as the release is progressing, how does Argo rollouts know that the release is successful? Does the release should be marked as success or it should be rolled back? The way it does is by what is known as an analysis run, right? So analysis template is a specification of the query, which rollout will query against the metric provider to understand whether the release was successful or not, right? So this metric provider could be Prometheus. It could actually be a Kubernetes job. It could be a webhook. So it could just be a GET request to a resource to say, okay, was the release successful or not? So maybe based on that response, the analysis run actually gets a result back. And based on that result, Argo rollouts is able to make a decision whether the rollout was successful or not. Wanted to provide a high-level overview of Argo rollouts to you as well. Again, lots of customers interested in this sort of progressive delivery in the Kubernetes environment at this point in time. One thing to take note is that Git Ops does not handle persistent application data, right? So if you have a stateful application and you have got persistent volumes and data sitting on storage backends, that is not in the purview of Git Ops, right? So it is suitable for stateless applications. Another example is schema-based deployments, database schemas, etc. They are managed outside of the Git Ops model, right? So that's why backup and restoration plans are still vital, still important, something that Yongkang is very passionate about. So you still need to make sure that if you have a stateful application with persistent volumes, you have a strategy to deal with their backups and restoration as well, right? And the third thing, the last thing that I wanted to talk about was EKS Blueprint. Not sure if Desmond and the rest of the guys are actually going to use EKS Blueprints in the coming up session. But I just wanted to talk about this particular project, which actually allows you to automate your cluster creation in 15 minutes or even less, Yongkang. So what is EKS Blueprints, right? So to run production grade workloads on an Kubernetes cluster, right? So you need a lot of operational tooling to be deployed in your cluster. So whether it is to do with logging, monitoring, security, policies, traffic routing, service meshes, whatnot, right? So you, for example, with Amazon EKS, if you create a cluster using AWS CLI, you get a functional EKS cluster, but can you use it for production without all of these operational software and add-ons that are required for day two? Probably not, right? And then because of this, we had a number of customers that built their own bespoke tool chains to deploy all of this operational software into the cluster, right? So you have a set of installation instructions, whether it is in Kubernetes manifest, right? So okay, run all of these steps and deploy Nginx in my cluster, right? So you spend hours building that sort of bespoke script tool, maybe bash scripts, Python, whatnot. It's still fragile, right? And you spend a lot of time just integrating different versions of different open source software, making sure all of them play nicely together and can work in the cluster. So the EKS team at AWS set about building this effective tool chain for you to bootstrap a cluster with all of these operational add-ons, right? This is an open source project with active contribution with partners and also from customers. And it's available in two infrastructure as code platforms, Terraform and CDK. So CDK is Cloud Development Kit that allows you to write infrastructure code in one of your popular programming languages, Python, Java, TypeScript. I've come to like TypeScript a lot. So it actually concisely describes the state of your cluster. And then boom, it's actually transformed into CloudFormation in the backend and executed on the cluster. Okay, so because it's all open source, it's either Terraform or CDK, we welcome collaborations and contributions from the community. So there are a number of modules available in this project, but if you feel that there is something that is missing, please feel free to go ahead and raise a PR. So what does EKS Blueprint solution actually give you? So it first gives you the ability to create the cluster, right? And you can run the cluster, at least in AWS environment, on two platforms. You can run them on EC2, which are our VM machines, Elastic Compute Cloud machines, right? Or you can actually host your workloads in a serverless environment called Fargate, right? So with Fargate, you actually don't create an EC2 instance. You just specify your pods, and AWS on the backend will actually create a micro VM to host that pod, right? So with an EKS Blueprints, you actually specify the configuration of these worker nodes. You might say, I want 3 M5X large to constitute my cluster. Additionally, I also want a subset of my pods to run on Fargate, and that is specified by the namespace and the selectors. So you can, with a combination of namespace and selector, you can specify a set of pods that will run on Fargate and not on EC2 instances. So you can use them together as well in the same cluster. Sorry. And then on top of the cluster, I think this is what we were talking about, the day two operational software. There are a number of add-ons that are available for you. And this is in Terraform, it is single line of code to say enable Argo Cd equal to true. And that's it. The add-on gets installed in your cluster, right? And same for CDK as well. So I have just listed a few of the add-ons in there. There are many more. Actually, A dot is not listed here. So A dot is an add-on that is available. AWS distribution for Open Telemetry is also an add-on that is available for you to install in your cluster. And again, it's actually declarative. You just declare that I want this add-on and it gets installed. You don't have to worry about the installation instructions. The benefit of this is, right, so when you're looking at your code, you're just, and if you want to diff from one version to another, you're just saying Argo Cd went from 1.x to 1.y. Right? That's the only thing that changed in your code, rather than looking at your installation instruction and saying what changed in my cluster configuration. So your cluster configuration is codified now, version control, and you can diff that. Sorry, I keep pressing the wrong key. And then on top of the add-ons, the blueprints allows you to create multi-tenant clusters, right? So a cluster that is used by multiple teams to deploy their workloads, right? So you could have a cluster that is specific for one particular team, and they are the only one using that cluster. But then you have operating models where multiple teams share a cluster, right? So what Blueprints does, it actually automates the creation of a namespace, attaches a quota with that namespace for the teams, right? So based on the specification. So if you want to spin up a multi-tenant cluster, you can specify that in code and the blueprints will take care of it. Yeah. So yeah, just talking about the teams, right? So you can actually create two types of teams in blueprints. One is the platform team, which has the ownership of the cluster, and then you have the application teams. So as I was saying, what does a team actually involve? It has a namespace, and then within the namespace, it attaches some quotas, which was specified by you in the code or the configuration. It also creates a role, a Kubernetes role that is used by the team to access the cluster. And the service account within that namespace is actually associated with an IAM role in AWS, right? So if your applications are deployed and need to talk to an AWS service like RDS, they need to have proper IAM credentials associated with them. And the way it works is you associate a service account with an IAM role in AWS. Yeah. And so all of this is automated for you as part of blueprints. So finally, just to recap, what do you get with blueprints? You get the ability to configure and stand up clusters. With blueprints, you can actually create a cluster in an existing VPC, or you can get it to create a brand new VPC for you. It will create a best practices VPCs spread across 3 availability zones and all the boilerplate around the VPC creation handled for you as well. Add-ons, as I talked about them. Oh, and then finally with tools like Argo Cd and even Flux, you will manage your workloads in a Git Ops manner, leveraging the continuous delivery and progressive delivery capabilities offered by those open source projects. Okay. So one more thing that I just wanted to highlight, I guess this is the last slide, is that once you have your code specified, right, in EKS blueprints, you are then able to reuse that code with a pipeline and actually instantiate multiple clusters across the regions or across the accounts, right? So you could actually instantiate a dev cluster, you can instantiate a test environment or a test cluster in same account or different account in same region or another region. So with pipelines, you even extend the capability of blueprints with it being able to deploy clusters in multiple accounts and multiple regions for you as well. The links are here, the 2 GitHub repositories for Terraform and CDK. And that's it. Thank you for your time.
Thanks, Keshav. Yeah, while I'm connecting my laptop, is there any questions to Keshav? That's a lot of loading. Has anyone tried the EKS blueprint yet? That is relatively also pretty new, right?
So
I don't see any question in the chat actually. Yeah. No question, yeah? All good? Can't wait to try. Yeah, can't wait to get your hands dirty. So the next part is we're going to get everybody to try to create a EKS cluster using automation. I haven't used basically the automation is based on the EKS CTL, the command line tool. And I also added a little bit is after you create the cluster, how to enable the container backups. So like I can show, use Git Ops or any other tools. That's primarily for the stateless application. When your whole cluster is gone, if you have the persistent data, if you have the persistent volume claims, that will be a problem. Your Git Ops doesn't cover your application data, the persistent data. So how many people joined the meeting last night for AWS user group? Well, that's good. So some of these I might duplicate it, but there is something new, definitely. So let's get started. I will go straight to, I will show you how to automate the whole cluster creation first. So basically, you just run one command, slightly different from yesterday. So yesterday I was talking about a deploy, but since we are using AWS account, I created the EE-deploy. That's based on AWS event engine. The AWS event engine, that's the on-demand lab platform, typically provided by AWS to customer partners for the loaning, for the demo purposes. So I'd like to thank Desmond to provide us the event engine access for us to actually gain the hands-on experiences. Where to download the code? So the same areas. So you clone from my GitHub repository, and then you get all the scripts. Yeah. Is the class name or instance type or region or bucket name, etc. And actually, yeah, I think we need us. You guys, are you guys interested in testing stuff? So I'm just figuring out guys are interested in it, you log into it, it's sort of
Hi, can you hear me?
Yeah. The question to those from joining us online. If anyone interested to gain the hands-on experiences, if you guys are interested, I created a spreadsheet. If you guys can put your name, so if you go to level 1, okay, level1.kasug.com, I will send in the chat window as well.
I'm not sure what the link is.
Let me send in the chat window, okay?
Okay, that's fine.
I will get you guys the Wi-Fi code as well for those who are here. Yeah, I remember. You give me 1 second. Yeah, let me. So I just shared the link from our chat window. Give me 1 second. So if you go to level1.kasug.com, so there will be a spreadsheet. Actually, let me move to the other screen. So you don't have to provide your number. I put here, for myself. If you guys want to, follow me, connect to me, feel free. So, and also your email address. If you guys need the lab access, you put your name here, and we will always share you the link. Yeah. By the way, the link actually, the link it wasn't correct yet. I need to wait, Desmond to get me the hash ID. Yeah. So as long as you guys put your name here, the Wi-Fi password, yeah. It's one word, broken wires at 2019. That's guest. The guest.
B's in caps, B and W is in caps.
Yes, B and W capital.
B and W is in uppercase, just a bit. Broken wires at the rate.
Hi, what is the
So
team
the
hash?
hash ID, once Desmond get it ready, I will share. Okay. So in the meantime, I need you guys to put your name, and then we will share you the hash ID. You can get the access. Is the two, yeah, makes it easier. Yeah. So let me come back to the slide. So very importantly, to spin up the whole environment, EE, that's the event engine dash deploy. We will spin up a EKS cluster first, and then install the backup tool, including backup. Yep, that's level 1. It doesn't work, the password. I don't know. Okay, let me continue to walk you through a little bit here. So I created a few, automation. Basically, the first one is automating the whole environment, including EKS cluster plus backup. So if you just want to EKS cluster, that's EE-EKS-deploy. So here is a scripts to get the details. And the next one is how to automate the container, backups. That's another script. That's a EE-K10-deploy. So that will just do the automation to enable the container backups, typically about 3 minutes. So here is a summary of the 3 key features. So when you use the EE-EKS deploy, only deploy EKS cluster. When you use the EE-K10-deploy, we will only do the container backup enablement. And the last one is to do the first 2 tasks together. And the good thing is that once you finish your testing, we also allow you to do the destroy, to clean up the whole environment. So the EE, the one is use the AWS account. But if you want to use your own account, you just remove the EE-. It also works. It also works for your own AWS account. Okay. So now, do we have the hash ID yet? You already updated. Okay. let me see how many people here. I can't see how many. Let me do a count. 22. 22. 2. Yeah, just in case some, maybe a few more will join, you know, make it 30, yeah, probably. Yeah, once you get the hash ID, you just think, I will send you guys the link as well. Yeah, otherwise you just do a Google search event engine, AWS event engine, you will find the link. And then with the hash ID provided by AWS, we should be able to get the access. Okay, I will copy here. Yeah. Yeah, everybody actually use the same link. Okay, you guys all have the access, right? I'm going to click this link as well. So it doesn't allow me to click. Yeah, let me copy. Hard for me. Let me bring it back. Okay. Oh, it doesn't allow me to bring back. Oh, come on. Actually, did I forgot to share the screen? I didn't. Yeah, just
யார போன் எடுத்தது யார் எடுத்து சொன்னது கரிகாலன்
sorry.
அப்பவாமாவா அப்புறம் எடுத்துட்டு
Is there any questions on the over the meeting?
Yeah. So
What's the question?
when I click the link, it says sign in with, and then it shows OTP login, Amazon employee. So
I not to mention here yet. Sorry, it's my mistake. Can you guys see my screen online? If you guys can see my screen, the next page actually give you another document. So basically, that's the lab guide I created it detailed step by step how to use the event engine to log into AWS cloud account. Basically, if you already logged in AWS account, use your own account or your company account, you need to log out first. I will copy you this link in the chat window for those of you joining online. So hold on 1 second. The chat window, I need to bring here. So the lab guides are from here.
Is it me or is the website not working for the AWS LD? Oh.
I just sent the link, the lab guide. So if you follow the lab guide, let me open up the lab guide as well. So basically it's a OneDrive share, the PDF file. You will see the details. Hold on 1 second, it's still loading. So that's the lab guide. Basically, Desmond and I, we created earlier.
Nice.
So let me make it bigger. Oh no, not this way. Should be using the, yeah, from here. Too big. Okay, so if you scroll down to the screen, you can see. So first of all, you need to click the link from the spreadsheet. And once you click the link, you will be asked to give you options how to sign into the account. You can choose either using Amazon, the login ID if you already have one. Otherwise, you just do the email one-time password. It will send you the password to log in. And then you will see the screen here. The next screen here is, so you can see open AWS console. Before you click open AWS console, you need to copy the environment variables. So that's very important. Without these, you can't get the full access. So once you copy this, and then you click open AWS console, it will take you to this page. If you already logged in, it will prompt you to log out your existing AWS account. Okay, once you logged in, yeah, for this case, you don't have to choose the region. We're using the US East 2 region. And then you can click AWS Cloud Shell. From AWS Cloud Shell, the first thing you need to do is you paste the token. That's the environment variables for you to get the access permissions. I don't know, anyone has questions from the online meetings?
Good boy.
Yeah.
Yeah, let me log in to show where. Did I copy the wrong ID? Hold on 1 second. Let me verify if the hash ID is correct. But it should not be. It shouldn't be ask me the hash ID if I use the link, right? But anyway, even it ask, you just provide, for those of you who ask the question, if it asks, you just provide the token ID, the hash ID. The hash ID is showing here. Let me also copy the hash ID just in case. Yep. Yeah. Okay. So yeah, I will log in shortly to show you. So the lab guide is here. Oh no, not this one. Sorry, let me write here.
Hi, for everyone
Actually,
in the,
if you guys want, you can join the Zoom meeting. I already shared the link in the Zoom meeting as well. Yeah.
yeah, in the lab guide link
That
is
would be
on there.
easier. You don't have to, find what's the link. You don't have the required permission. So from Dave, if it says you don't have the right permission, typically it because you did not copy the environment variables. So you follow the guide, you copy the environment variables, and then it should be all good. So for me, let me log in, just use Amazon. But either case it should be okay. I want to need a Desmond to verify, yeah, if the hash ID is okay. I tried it from my side, also doesn't work. You already see people logging. Okay. Copy my side. Let me see. Oh, it's already gone. Oh. 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 So how many you created? 22, exactly 22. Oh. Okay.
Yeah, it's asking me for like a kind of access key ID. Do you know what I put there?
If that one actually, if you're using the AWS event engine, you can just cancel that one. Otherwise, you can copy from the environment variables. So from the beginning, there is a copy button. You copy all the environment variables. One of these is access key ID. The other one is the secret key. You just paste it here.
Oh, okay, yeah. I'll do that.
Yeah, you find that? Okay.
Okay.
So I want to be able to show you here. Yeah, since I don't have the access now. Okay. Yeah. Thanks. Yeah, once I got the token ID, I can log in as well to show you how it works. But let me share my screen. Which screen I'm going to share? It's from the Meetup. From the comments area. Can you see? If not, let me send you.
For the Zoom link. Zoom link. Yeah. Because we are not getting yet Meetup. Oh, we have put Zoom. Oh yeah, yeah, no, you went there. Oh, thank you. Yeah, it was a Zoom.
Are we all good? Access?
I can send or catch, check the.
Okay.
I send it, I created form, send it to the rest in this.
Yeah, for those of you who can't log in, so from the spreadsheet, we just added another link. So in the line number 10, you can see the new link. It will take you, give you the access. If I'm going to copy the new token, the new hash ID here, it should work now. Let's see. Yep, now it works. So if anyone has any questions, feel free to ask. So once you're here, you can click AWS Console. I'm actually not sure. Can you guys see my screen from the Zoom meeting? Can you guys see my screen?
Yep, we can see your screen.
Okay, good. So once you click the link, here is very important. This is a copy button next to Mac or Linux. You click this link, it doesn't give you anything. So you don't know if it was copied or not, but once you click it, it should copy it. If you're not sure, you can just copy paste it below. Yeah. And once you copied this, you can click Open Console. And from here, we will log you in to the AWS cloud. So for now, I just logged into AWS cloud. And from here, the next step is we're going to click the Cloud Shell. It might take 2 minutes to be ready. Once it's ready, we need to paste the token code here. Actually, it's pretty fast. You just paste all your token, all your environment variables here. Mm-hmm. Oh yeah, yes, yeah. So you paste your environment variables here and press enter. And two of the environment variables is access key ID and the secret key ID. Are you guys with me here? Yeah? All good? Cool. So if I look into the document, I also need to look into the document. So the next step is we're going to clone the repository. If you don't want to copy from the document, you can go to the GitHub page. So basically, I copy from the lab guide. I copy the command. Let me make it bigger. Yeah, can you guys see? Okay, we clone the repository, press enter. And the next step is we're going to run the AWS prep command. Yeah, basically the AWS prep command, we're going to install the related tools like a kubectl, Helm, and the EKSCTL. We use the command to install to do the deployment of the cast and create the cluster. So from here, it will ask you the AWS access key, secret key. Actually, it's from the previous window if you made a copy. But actually, for this environment, we don't really need the AWS key, access key, secret key, because we are using the IAM rules. But if you use your own AWS account, you're not using the EE-deploy, you will need the AWS key, access key, secret key. So for these cases, I just, I cancel this one. So basically we're ready to go. The next step is you just run EE-deploy. The last step, so basically you change it to the directory, you run the AWS script. Did you have the access to the lab guide? Yeah, that's the step. So once this step done, you just run the deploy. But if you, from the last step, if you really want to put the access key, secret key, there is no issues, okay? But you don't have to for this case. But if you are using your own AWS account, you definitely need the access key, secret key. Okay, I'm going to run this command. So from here, it does take like about 20 minutes. 15 minutes for the EKS cluster, and then about 3 minutes for the backup, enable the container backups. For most of the time, I can say is just about 80 minutes. Yeah, sometimes it could be as long as like 20 plus minutes. Anyone has questions from the meeting, Zoom meeting? We moved here. Let me check. What's the? We will create a separate EKS cluster. The cluster still created using the EC2 instance. So when you do this, right, these dump charts are actually automating the process of doing all of this provision, the access, all the clusters, the secrets and all the other things. It's automated. That's why it takes. for example, I need to ask if the products we can use our own IDs.
Yeah. That is correct.
Let's say that I'm running this whole thing for AWS. How much is it? How much is it? If I forget how much I'm going to pay.
No.
Very important thing about AWS. If you position things like this, it's gonna work. But once you leave it running by itself, that's where we see. But there are ways to actually help you. If you run some sort of forward reports, utilization reports as well, then you put a threshold. And it happens. If you shoot out email, hey, why is this still charging me? It will send that. There's even a few ways that to shield workloads, lambda functions, and all this shield workloads if it's triggered by firewall. So lambda functions functions as a service. It runs as long as you invoke the service. It runs and then it shuts down. So you can get code to trigger alarm to you as a user, tell you. At the same time, that alarm triggers lambda queues for that function. That is for testing purposes. Go through that information. Hey, why is this being queued? Right. So testing. I think but there are ways cost optimization. Because AWS runs it, cost optimization. Notice the setting point. But one is cost optimization, how to get that long S3. Because S3 is just keep piling on, your bills are just if you see suddenly spike in right? Google conceived conditions are having so now all S3. Why is now all? Why is possible? Right? So there are papers I can share with you. It's not just on when you do this. Out of this one more question. Do you have anybody knows the account that is something that my Does anyone have any tool or something? Because usually I spin up machines in the automation. Sometimes automation fails and my institute instance is there. Is there any way I can just keep my account and go and check all the institute instances? Let's just give me a report. Killing I can decide with whether I want to kill it automatically. No, that data is too far. I cannot reach back. Because sometimes I speak. So that you can put us to actually on. Just search eventually. There is one. I can put a config as there's one column, even because even can use cloud host even which is actually a bridge, right? Yeah, it's a workflow mechanism that triggers multiple things. But that's a few. There's no one way. There's two ways to do what you want to do. You have an option to go with an IC solution that can do that for you. Monitor that while you run. So chargeable, right? The other one you don't want to get charged is Event plus a few other things. Let me get that. So call to action for this is.
Are we all doing good? Yeah, it's creating the EKS cluster right now, right?
It does take like 15 plus minutes for the. Yeah. Yeah. So to answer that question, let me show you one of the slides here. So this is typically when you have an EKS cluster or any other Kubernetes cluster. Why it doesn't go back? Yeah. Okay, sorry. So you got the work nodes actually for Amazon EKS, it will be based on the EC2 instance. It's up to you how many nodes you need. Why it moves so quick? It's crazy. Let me come back. Sorry, let me bring it back. It's here. Yep. So when you create the cluster, you can say, I want to create a one work node minimum, and you can set the maximum as well. It can be auto scaling. Yeah. Does that answer your question? Who is going to schedule the workload? That's the scheduler. That's the Kubernetes scheduler does the job to say which node got free resources, and I'm going to schedule the job to that particular workload. Yeah. Yeah.
Service to communicate to Kubernetes. If Kubernetes have to communicate outside, how exactly to do that?
So typically,
for example, is weather service you want to consume data from it.
Yep.
Sorry, it will be very dumb question, but
It's all right.
From last 5 days,
Mhm.
I'm confused how to get out there because Kubernetes Excel, everything is blocked. To come in, I can get the request. Going out, I'm still confused. How do I go out and because what service should I open so that the communication can happen? Because I'm not able to go out to get the data. If I have to open, I have to open the complete test to go outside and
it is actually, it depends, you know, your application, your service. Typically in the Kubernetes world, you got a lot of different containers. It's microservice based on microservices architecture. You have your web service, your different, you know, services. It could be also database application, middle tier, front tier, and in each tier, you have, you know, the services that can talk to each other, right? And how to provide the end user to access typically by the front end. Your front end application, whether the external access, the rest of the middle tier or, you know, backend are not going to typically not going to provide that direct access to the external users. Mm-hmm. Yeah.
Which give you the correct weather, it advise you whether you should go right now to run or not.
Mm-hmm.
Okay. To make this app, goes to check the current weather, check the humidity, check the how exactly sun is there.
Yep.
16. So the information is like data you require.
Yep.
Okay. This case, how you should communicate because you have to go to public services.
Yep.
Get this information. It cannot. So internal communication, yes, those can talk with each other.
Mm-hmm.
When you have get the external service fetch the information. What now I'm doing is I'm running a cron job, which 30 minutes, fetching the data, putting in the database. Okay, for next 2 hours, and from the database, I'm able to do it. I want to make it live so that these dependencies does not happen. The problem is I'm not able to go.
What?
You want to outbound access, there should be a service on Aws running. Okay, you want to see if I define out. Problem is if I completely stop the world running, then I'm directly able to access something. But the moment I limit the scope, only give the specific service to access, it's good.
Yeah, you probably need a net gateway to be able to access external.
It's very yeah, it's just very even there's no such thing as unless you said it. So yeah, like at least it's more than enough. So I don't the moment the person told me network is the first block of people have Kubernetes. That's like okay, he's not 40 and I have one of them connected with sure. Yeah. And you know we can add that. Share it. No problem. So we can take it. Sure, maybe that's simple. Very simple. Simple one. Then export that to the and then export it. So again, Kubernetes one-on-one kind of a session. Yeah. Then all this cluster nodes, all the things I want. Yeah, let's proceed for this. Thank you.
Yeah, we are almost 9 o'clock. I don't know, Desmond, are we still able to continue a little bit time or? Okay. But anyway, as Desmond said, you know, yeah, I think as Desmond said, you guys do have the access for 24 hours, right? So if you guys want to have a little bit of homework, you guys can continue tomorrow. I don't think any limit, right? Oh. So you guys might have noticed here, we actually, it take 16 minutes, 16 and a half minutes. The EKS cluster is up running. Enable the container backups. So where is my mouse here? So I choose here. It should be all good. Yeah, I guess as long as you guys follow the lab guide, you should be able to try additional stuff. For now, I just showed you how to launch a cluster, enable container backups, also part of it. But how to recover the individual spec artifacts or resources, how to do the full restore of the containers. It's all in the lab guide. We want to be able to spend the whole night do all the labs. But I guess you guys are already up to a point, already launched the cluster, already automated the cluster. You should be able to continue to complete the rest of the labs. Sorry, what's the question? The lab guide link. It's here. AWS-LG lab guide -EE .yongkang.cloud. So once you got the environment ready, I put here is you can explore the different recovery options. You can do the in-place full restore. You can do the restore to a new namespace. Basically, you clone from your existing one to a new one, or you can do the individual spec artifacts recovery. Yeah, pretty handy sometimes. And you can do the restore from Amazon S3 bucket. And what else? If you guys want to try step by step manually, so because of part of the automation, we even deployed the database also automatically. But if you want to try deploy a sample database like a PostgreSQL, I got the instructions how to help me install a PostgreSQL. And once you install another database, you can try how to create a backup policy, how to create an Amazon S3 bucket, how to do the restore. Any question? We are all good?
Let's say after the deployment, clear that CLI. What's where you're working? You display the config URL or at the end of the deployment. At the end of the deployment, then you log into.
Yeah, that's.
Clear the screen then. Could we clear the screen?
So basically, that's the one. Yeah. So.
So you have to go back to the CLI, copy the export again, paste it there, again the CD one, the first line.
Yeah.
Then you can put the first part you've done, then you can put the second part.
That's right.
They already have EKS ready. Yeah. K10 deploy. You can do the second step.
Yeah.
I know.
But just make sure for we are using the AWS provided access. You need to use the EE dash K10 deploy. Oh, well, that's your question. Yeah. I forgot to add to the lab guide. What you need to do is just run cat to the EKS token. It will give you the link and the URL, the token and the link. Yeah, it's a secret. Yeah, if you clear the screen or you accidentally timed out, you won't be able to see, right? You just come back to the command line. You need to change it to the EKS K10 directory. So we save the, yeah, EKS underscore token. It's EKS underscore token, yeah. So inside of this file, you can see the URL to access the web console and also the token code. So if you want to log in, you just copy the link to a new tab, and then you will be asked to provide the token. Let's see if we have time. Yeah, I'm going to show you the link here. So I'm going to paste it here. And then you will be asked to provide your token to access the console. So come back to the Cloud Shell and copy the token. Then paste the token here. Press sign in, and we will log into the web console. Actually, once logged in, it's so easy, so simple to use. You will figure out how to do the backup and the recovery. Yeah, you log in, you already see my backup job is already finished. So the backup policy also created. My sample application also deployed. From my lab guide, I also have the instructions on how to deploy additional sample database. Yeah, and you can try all different recovery options, and Amazon the settings. So I created the Amazon S3 bucket here. So that's why we use to make another copy. So let me show you why we need to make another copy. This is also very important. So I use both of the cluster running on Amazon EKS. Let's say from here, when I do the snapshot, basically you take a snapshot of all of your applications, your application components, your Kubernetes configuration, and the persistent volume claim data. So make sure when we do the snapshot, we capture everything from your application namespace. So that's where we do the application configuration and the data snapshot. But all of these snapshots still sitting within the same cluster. You might use EBS or EFS or any other CSI. It doesn't have to be EBS or EFS. But our constant K10 also installed in a separate namespace. We also have our own catalog of metadata also stored from the PVC, the persistent volume claim. If somebody deleted the whole cluster, or maybe the whole data center is gone, you actually can't recover, right? You understood this situation. That's why it's super important to always send another copy to external, Amazon S3 or any other S3 compatible. That will be a lot of safe, a lot, reliable. Even ransomware attacks, you enable object lock, you can create the backup immutability. So there is nobody can attack your backup data. So that's super important. So that's basically up to here is how we do the backup. We take a snapshot of the whole application, everything backed up, and then send another copy to external S3. So in case the whole data center is gone, you can still recover from our S3. The S3 can be far away from your primary EKS cluster. So it can be different geo, different region. Okay. And now the good thing here is, I give you an example. AWS have the region here in Singapore first, before launching in Jakarta. Now customer want to move back to Jakarta. How we can help you to move the containers to Jakarta region? Since all of my data already sitting from the Amazon S3, I can easily do an import to my target cluster. You just spin up a cluster from our Jakarta region. It's an empty cluster. It can be running different version, can be running the newer version. And then custom K10 installed here. Now, not just import the restore points, we also allow it to do the restore. Once the restore finish, everything supporting your MySQL application will be here, including your persistent volume claim, your pod, your config maps, anything we recovered here. Typically for smaller applications, I tried, you only need like 3 minutes. Seriously. I recorded probably totally 9 videos talk about the migration. Could be from on-prem to AWS, could be from AKS to AWS, EKS. So that is also possible. Typically only like 3 minutes we can make that happen. But for this particular lab, we only do the first part, do the backup, do the export to Amazon S3 to explore all different recovery options. But in the future, we're thinking we might do a session, talk about the migration stuff. It's super important. A lot of customers initially running from on-prem, or maybe you want to help them to move from other cloud to a different cloud. So this makes life a lot easier. Yeah, question?
Then is this able to do like a cross account kind of backup?
Sorry, who is asking?
I'm asking.
From Zoom.
Okay.
Sorry.
Yeah. Oh, so the question is,
I was
you
trying to
said-
figure out where the
Yeah, so the question was, you said you can do cross region, but then
yes.
is it possible to do cross account as well?
Actually, it's not. It is more than cross. I love AWS. That's why I listed here Amazon EKS to EKS. It can be from other cloud to EKS. It could be from EKS to other cloud also possible. Okay, I'm not denying the facts. It, yeah. Yeah. Because it's incremental typically.
But if there's new bugs, which by change.
Yeah, that is a very good point, actually.
Okay, so is there a way that we might export that out? Oh, yeah, but snapshots will capture that. It's just that if other ways.
Yeah, I just want to add another point here is, use this way also can simplify upgrade maintenance. So not only allow it to move from one cluster to the other, can be completely different Kubernetes distribution. You might want to move from a Rancher or OpenShift or Tanzu to EKS. It is possible, and it can be from a completely different version. And how we can simplify the upgrade, I want to explain here. Maybe today you're running from let's say left-hand side, you're running 1.20, but you want to upgrade to 1.22. But how to do the upgrade? If you do the in-place upgrade, a lot of surprises. You might realize your kernel YAML file, all of these working perfectly. But when you do the in-place upgrade to 1.22, a lot of API changes. Some of these deprecated API. And then you will realize once you do the upgrade, once the upgrade finishes, some of the application might stop working. So by doing this approach, you just spin up new cluster 1.22. You do the backup from a 1.20. We're going to restore you to the new cluster. It's already running 1.22. Because part of the solution, like a constant K10, it does the powerful transformation engine. It understands the differences between the two clusters. So it will allow you to easily to do this simplified upgrade maintenance. Any other questions? I thank you guys, so much, engaged and, so many different questions. I hope it is very useful to you guys. And by completing the lab guide, definitely you are, almost an expert talking about the container backup, container recovery, how to do the migration, etc. Yeah. I pretty much use a lot of different stuff, WhatsApp, if you guys are interested, you add your email. We can create a WhatsApp group. Thanks everybody for joining us.
Thank you, everyone.
For those of you over the meeting, any other questions? But you guys can continue to try to complete the labs, tomorrow if you guys are interested. Seriously, yeah, AWS providing you guys a free access. Why not leverage? Yeah. So. There is a question from online. Let me. Oh, nice. Let's take a group of picture. Yeah. Yeah, feel free to put me, by any one of the ways.